Today we're going to take the derivative of the fourth tetration of x, which this can be rewritten as, let me just put it over here, 4x. I mean, it's like an exponent, but in the wrong place. That's the fourth tetration of x, so that's just a little side note there. But yeah, this is the fourth tetration of x, and we're going to take the derivative of it. So remember in the last video we went over the second and third tetrations of x. Their derivatives are right there. That will be very useful in today's video. So, how do we do this? There are actually many ways you could do this. Some are more complicated than others, but I'm going to show you two ways. One involving this one and the other involving that one. But we will need to use one either way. So, how do we do this? Well, let's start by doing what we normally do with our logarithmic differentiation and set y equal to our function. Okay, so y is equal to this. Okay, so now we're going to take the natural log of both sides, and I'm actually going to use a red marker here. And I'm going to do this. Okay, so y is equal to that. And I'm just going to take the natural log of both sides, because this way I can pretty much use log rules to bring powers to the front and all that. So this just becomes natural log of y, okay, and that is equal to, well, we bring all of this to the front, all those exponents, x to the x to the x times our natural log of x. And this brings us to our first method, because you can right off the bat just notice that this is just the product rule, and we already know what the derivative of x to the x to the x is, and we know this is 1 over x. So we know both of these derivatives, so we can actually just do this right now. So here, since it's implicit, we have to do 1 over y times our dy dx, or just y prime. We just make that prime a little more obvious. And that is equal to, I'm going to start by writing out the function, so it's x to the x to the x times ln x, I'm sorry, the derivative of ln x, which is going to be 1 over x. Okay, and then we're going to add, let's just add ln x, and then times the derivative of this function, which is that catastrophe. So x to the x plus x minus 1 times x ln squared x plus x ln x plus 1. Okay, so this is our formula. Now we just have to multiply out our y, which we said was x to the x to the x to the x. So y prime by itself is equal to, I'm just going to write this out in red, x to the x to the x to the x. Now we can actually multiply this. This is just x to the negative 1. That's just what 1 over x is. So I'm going to write it like that. So we have x to the x, and then this minus 1 since we're multiplying by it. And then plus, well, see, this natural log is kind of awkward there. So I'm going to multiply it out to all of these, just, to help us out. So, yeah, so we have x to the x to the x plus x minus 1 times x ln cubed x plus x ln squared x plus just a lonely natural log of x. And that is our derivative of x, the fourth tetration of x. Again, let me close that one parentheses over there. Again, you could rewrite it in different ways. I know Wolfram Alpha has a similar but slightly different way that they did this, and you can get different answers depending on different methods. You could stop here, you could simplify more, you could have stopped here, obviously, by multiplying this. You could just multiply this by all of that and it'll still be fine. It's just not going to be as simplified as possible. I mean, actually kind of is, but, for completeness. Okay, So now I'm going to show you a second way of doing that, and that's going to utilize this derivative formula. Alright, now for the second method, I'm going to go through this a little quicker. Alright, and now for the second method, I'm going to go through this a little more quickly, just because it's, we already did one method, so I'm just going to run through this pretty quickly. So, again, we're going to start by setting y equal to x to the x to the x to the x. Alright, same deal, we take the natural log of both sides. I'm just going to write it out. ln y is equal to x to the x to the x times ln x. Right, same thing that we had. This time we're going to go a step further, and we're going to take the natural log of both sides again. So of course, on this side we'll have natural log of ln y, so ln of ln, and that's equal to, I'm going to write it out this way, so I'm just going to do it like that. And you might be thinking, oh, just evaluate it. But you have to remember, you can't just you can't just be like, oh, this is x to the x, ln x. No, because whenever you have two products, two things, if you're multiplying two things inside of the parentheses, you have to separate it into two natural logs and add them together. And I'll show you what I mean. So natural log of ln y is equal to, so I'm going to take this natural log and add it with this other natural log. So I'm just going to evaluate this. This is just x to the x, ln x plus ln of ln x. So just something to keep in mind, not to mess up with. So that's why I think this is better, just stopping here and taking the derivative, as long as you know this. But okay, so let's just evaluate this. So this is going to use the chain rule pretty much twice. So this is 1 over ln y, and then times the derivative of the inside, which is 1 over y, and then y prime. That's going to be equal to, x to the x times 1 over x plus ln x times now the derivative of x to the x, which is simply just x to the x times 1 plus ln x. Okay, and then we're going to add to this pretty much the same thing as that. So 1 over ln x times 1 over x. Okay, so that's pretty straightforward there. Now I'm just going to isolate our y prime. So y prime is equal to, okay, so I'm going to multiply both sides by y and ln y, since we have to isolate that, and so we know that y is this and ln y is that, so I'm just going to kind of, since I multiply them together, I'm just going to combine it in one step. So we have x to the x to the x to the x, that's our y, and then I'm going to take this, and since whenever you multiply these two, you add the exponents, so I'm just going to add a plus x to the x times ln x, so that's that, and now I can multiply. This is x to the x minus 1, because that minus 1 again, plus, again, this ln x is kind of awkward there, so I'm just going to do this x to the x times ln x, actually I'll just reorder it, ln squared x plus ln x, alright, so, okay, let me just make sure I'm not, okay, so this is all in the parentheses, yeah. So then plus 1 over just x ln x. And I am aware that Wolfram alpha has a different way, so I think they just multiply this by x ln x and all that. I could actually distribute this ln x, so let's just do that in this step. I think that would make more sense to do. So y prime is equal to x to the x to the x to the x plus x to the x times, okay, so then we have this just x to the x minus 1 ln x plus, I'm going to actually multiply that out here, so x to the x times ln cubed x plus ln squared x plus, and then ln x times that is just going to be plus 1 over x. And I could keep going with other things. I could multiply everything by x and put a subtract 1 here. Up to you. So I'm actually just going to write this as x to the negative 1. And I mean, yeah, actually it would make sense to do that. So let's do that. And you know, simplifying is always important. So x to x plus x to the x. And then I'm going to do a minus 1. I'm going to factor out the minus 1, or the exponent of minus 1. So this just becomes x to the x, ln x, plus x to the x plus 1, since we're factoring that out, times ln cubed x plus ln squared x, and then plus, so just x. Wait, hold on, that's there. Actually no, just plus 1, since we factored that out. So yeah, that should be correct. I should double check that, but yeah. I think this is pretty much close to the Wolfram alpha definition, or answer if I'm not mistaken, but yeah. Any of these 3 answers would be perfectly okay as long as they're correct. And so, again, this is a lot of work, so I would prefer using the previous method where we just stopped here and took the derivative, and we basically found the answer right away, but up to you. Yeah, so that's the derivative of the 4th tetration of x in 2 different ways. From now on, I'm pretty much going to use this method where I take the natural log once and then find the derivative of the entire function using the derivative of the previous function. So I'll have this answer written out for the 4th tetration of x in the next video. So yeah, thank you for watching, and I will see you later. Bye!